Hello dear students of +1 medical, non-medical, respected teachers and dear students. In this video I am going to discuss about thermodynamical processes. I will discuss 4 thermodynamical processes and application of first law of thermodynamics to these processes. So first process is known as isothermal process. It is that process in which pressure and volume change but temperature is kept constant. So P and V change, T is kept constant. So it consists of 2 parts. Number 1, isothermal expansion. Suppose we have a cylinder having perfectly conducting walls fitted with perfectly conducting frictionless piston containing 1 mole of ideal gas at pressure P, volume V, temperature T. Now, suppose this piston is allowed to expand slowly at a very slow rate. When this piston is allowed to expand slowly, volume of the gas will tend to increase and hence temperature of the gas will tend to fall. Therefore, but as it is in thermal contact with the surroundings, because walls are perfectly connecting, so heat flows from the surroundings into the gas so that temperature is kept constant. So in this case of expansion of gas, volume increases when piston rises, but temperature is kept constant as it is in thermal contact with the surroundings. So this is the case of isothermal expansion. Then isothermal compression. Again, suppose we have a cylinder having perfectly connecting walls fitted with perfectly conducting piston, frictionless, so that can move up and down freely without friction, containing 1 mole of ideal gas, pressure P, volume V, temperature T. Now what happens when the gas is compressed slowly? Then volume of the gas decreases. When volume of the gas decreases, temperature of the gas will tend to increase. But as it is in thermal contact with the surroundings, so heat flows from the gas into the surroundings. Again, temperature is kept constant. So therefore, this is the case of isothermal compression. So in both the cases, temperature is kept constant. Now, what are the conditions necessary for isothermal process? Number 1, walls of the container must be perfectly conducting. Number 2, this process should be performed at an infinitesimally slow rate. It is a slow process. So these conditions must be maintained. And if you plot PV diagram, graph between pressure and volume, so it comes out to be like this, curve like this, P1, V1 initial pressure volume, P2, V2 final pressure volume. So this graph comes out to be a curve like this. And we'll find work done during this process in next video. So if you apply first law to this isothermal process, first law of thermodynamics. So we have dq is equal to du plus dw by first law of thermodynamics. So since temperature is kept constant in this process, so it means there is no increase or decrease in internal energy of system because internal depends only upon temperature. So du is equal to 0 or therefore dq is equal to dw. It means amount of energy supplied or taken away is equal to amount of work by system or upon the system. Then second process is known as adiabatic process. It is that process in which volume and pressure change but temperature is not constant. Temperature doesn't remain constant. Suppose again it consists of 2 parts, adiabatic expansion and adiabatic compression. So first is adiabatic expansion. Suppose we have a cylinder fitted with perfectly non-connecting walls and perfectly non-conducting piston which is frictionless, containing 1 mole of idle gas at pressure P, volume V, temperature T initially. Suppose this piston is allowed to expand, move up, piston is allowed to rise, then volume of the gas will increase, and hence this piston is allowed to rise suddenly and volume will increase, but as it is thermally isolated from the surroundings, so temperature of the gas will decrease, temperature will fall. So temperature decreases when gas expands adiabatically. Then adiabatic compression, when gas is allowed to compress suddenly, piston is moved downward suddenly, then volume decreases and hence temperature will increase. Volume decreases, temperature will increase as it is thermally isolated from the surroundings. Walls are perfectly non-conducting. No heat allowed to enter or leave the system. So therefore, during this adiabatic compression, temperature of the gas rises. So these are two cases of adiabatic expansion and adiabatic compression. Now, conditions for this adiabatic process should be sudden and walls should be perfectly non-conducting walls. Perfectly non-conducting walls. In case of adiabatic process, no heat is allowed to enter or leave the system. And if you plot PV diagram or indicate diagram for this process, it comes out to be curve like this, and which is more steeper than the corresponding isothermal curve. So it can be proved mathematically also by finding its slope. So PV diagram for adiabatic process is more steeper than the corresponding isothermal. If you apply first law to this process, as no heat is allowed to enter or leave the system, so dq is equal to 0, so du is equal to minus dw from first law, so therefore du is equal to minus p dB. When gas expands during expansion, dV is positive, du is equal to negative, that is internal energy decreases. During compression, dV is negative, volume decreases, so therefore minus plus, so du is equal to positive, it means internal energy increases. So internal energy of the gas increases during adiabatic compression and decreases during adiabatic expansion. Then third process known as isobaric process. In case of isobaric process, pressure is kept constant. For example, when a liquid boils or say water boils at constant temperature, and its temperature is also constant at the boiling point. So till whole of the liquid converts into vapors, so volume will change. So therefore dW is equal to PdB, that is P into Vf minus Vi. So temperature is kept constant, so we have to supply energy at the constant rate. So Vf is the final volume, Vi is the initial volume, so dW will equal to pressure into change in volume. We have final volume minus initial volume. So if L is the latent heat of vaporization, so amount of heat required to convert 1 gram of liquid into vapors. Okay? So if m is the mass of liquid which is converted into vapors, so amount of heat required will be dq is equal to m into L. So from first law, so du will be equal to dq minus dw, or it will be ml minus p into vf minus vi. So this is isobaric process. Pressure is constant, volume changes, and we have to supply continuous energy so that water is converted into vapors. Liquid is converted into vapors. This is first law for isobaric process. Fourth is isochoric process. It is that process in which volume is kept constant. If volume is kept constant, dW is equal to PdV is equal to 0. It means dQ is equal to du. So it means amount of heat added or subtracted is equal to amount of increase in internal energy of the system or decrease in internal energy of the system. Amount of heat supplied is used to increase or decrease the internal energy of system. So these are the four thermodynamical processes, that is isothermal process, adiabatic process, isobaric process and isochoric process. So in next video I will discuss work done during isothermal and adiabatic process. Till then, stay tuned, be happy, all the best, good luck.